Hello and welcome back. So in today's videos, I'd like to use a very simple example to wrap up what we have learned so far. So here, also this is something example I used before. So here we have the independent variable x, which represent year of education, and our dependent variable y represent the monthly income. So now we only have 4 data. Okay, so I just make up, faking this number, so it doesn't really have any realistic meaning. I just wanted to show you the calculation process. Okay, fine. So for example, here we have like 12 years of education, and then the monthly payment is probably going to be 6K, and also a university student, a graduate, and monthly payment is going to have 8,000, and another university students, and the monthly payments like 7,000, and finally we have a PhD student, and monthly payment is going to be 10,000. Okay, cool. So the thing we need to find out is, first of all, the estimator of alpha and beta, and also the each individual residual term mu I, mu I hat, and also the estimator of the sigma square, and finally we'll do test the statistics of the null hypothesis of beta equals to 0. Okay, cool. So let's do it one by one. So first of all, like the estimator of beta, right? And remember, we have the expression of beta, which is going to be equal to the sigma of xi times yi minus n times x bar y bar divided by the sigma of xi squared minus n times x bar squared. So now what we're going to need is the average of x and y, and also the sum of xi, yi, and this term. Okay, so let's do this, step by step. So the sum, let me write it here, and the mean. Okay, mean. Okay, so let me use my calculator to do that. So the sum of x should be 12 plus 16 plus 16 plus 20. It's going to be 64. Okay, and divided by 4, it's going to be 16. And for the y, it's going to be 6 plus 8 plus 7 plus 10, 31, and divided by 4, it's going to be 7.75. Okay, now we also need the x times y. Okay, so for our first instance, we have 12 times 6 is going to be 72. Okay, I'll just use my calculator and do them all, and this is 128, and that is going to be 16 times 7 is going to be 112, and finally this is going to be 200. So together the sum of this term should be okay, cool. It should be 512. Let's see. We also gonna need the sum of xi squared. So let me write it down here. So x squared. So again, let me use my calculator. Yeah, this is also the reason why I only chose 4 data, because if the number of data increases, the amount of job that I have to do will also increase. So I just kind of cut me some slacks. This is 256, 256, and this should be 400. Okay, the sum of it should be okay, 1056, and I think that's probably all that we need. Now let's just plug in for each individual term. So we have the sum of this is going to be 1056 minus n is 4. So 4 times the mean of x is 16 times 7.75. Okay. And divided by the denominator is going to be, I'm sorry, I made a mistake. So this is actually the sum of x times y, so it's going to be 512. So for the denominator, it's actually going to be 1056 minus 4 times the mean of x take squares, which is 7.75 times 7.75 is going to be okay. So it looks a bit weird. I hope I didn't make any careless mistakes. Hold on. So I'm sorry, I made a mistake. So this 16 times 16 is going to be, and times 4, yeah, it's going to be 256. And this is going to be, let me use my calculator again. So 4 times 16 times 7.75. So it's going to be, okay, so it's going to be 512 minus 496 divided by, I think this is going to be this is going to be 32. Okay, which just happened to be, I think, yeah, just happened to be 0.5. And that's for our estimate of beta. And for estimate of our alpha, and that's going to be the mean of y minus beta hat times x bar. And we just, again, plug in, then we have y bar is like 7.75 minus 0.5 times 16 is going to be 8. So it's going to be minus 0.25. Okay, this is for our question 1. And for question 2, remember, in order to find the mu hat, we know that mu hat is going to be equal to the y minus the x hat minus beta hat times x. So since we already know the alpha hat and beta hat, so we just plug in like x and y respectively, then we will just get the mu hat respectively. Okay, so let me write it down here. So for mu hat 1, alright, so for mu hat 1 we have, so let me write it down here. So mu hat 1, it's just going to be equal to, so y1 is going to be 6 minus okay, let me write it this way. So plus 0.5 times 12. Okay, that's cool. That's going to be equal to 0.25. And mu hat 2 is also going to be 8 plus a minus 0.5 times 16. And it's going to be, this is also going to be 0.25. And for mu 3, we're going to have 7 minus plus this term minus it's going to be the same, so it should be minus 0.75, right? Okay, it should be correct. So for mu4 we have, okay, 10 minus 10 plus this point and minus 0.5 times 20. So this is going to be, again, it's just going to be 0.25. So for our mu, the residual term, we have 0.25, 0.25 minus 0.75 and 0.25. Okay, so now for the question 3, we need to calculate the sigma hat square, which is going to be, so for question 3, and sigma hat square is going to be, remember, like it's sigma hat square, it's just going to be equal to 1 over the degree of freedom in this system, which is 4 minus 2, and times the mu hat square, the sum of mu hat square. So let's do this for real quick. So mu hat square is going to be equal to, so this is going to be 0.0625, 0.0625, 0.0625, and for the third term is going to be 0. So this is going to be 0.5625. Okay, I hope I didn't make any mistakes. So let's see. So the estimate of sigma square is actually going to be, let's just sum them up. It's going to be, so the sum of this term is going to be 0.75. So the 0.75 times 1 over 2 is just going to be 0.375. Okay, so yeah, that's the estimate of our sigma square. And finally, if we were to do the test statistics under the hypothesis that beta equal to 0, we just need to compare. Let me try to find the t distribution table. The significance level of 0.05. So the t of 0.05 divided by 2 of the degree of freedom 2 is going to be, this value is going to be equal to, let me check. So it's actually 4.303. So we need to compare. Well, we need to, the t value for this hypothesis is going to be beta minus beta, beta hat minus beta, but beta is equal to 0, and divided by this term, divided by our sigma hat square over the xi minus x bar take square. So let's plug in. So now we know that the beta hat is 0.5 minus 0 and divided by our sigma square is 0.375 divided by, okay, so this term is exactly the same as this term. So this is going to be equal to 33, I guess. 32, I'm sorry. So let me use my calculator again. 0.375 divided by 32 is going to be, okay, so let me just rounding to 2 decimal places. So this is roughly going to be equal to 0.5 divided by 0.11. Okay, so this number is going to be roughly going to be, which is going to be 4.54. So this number is actually greater than the 4.3, which means we should reject our null hypothesis. So the null hypothesis of beta equal to 0 should be rejected. Okay, this is pretty much it for the whole process of how to calculate something related to the simple variate cases of our OLS model. And I hope this can be a little helpful. And alright, so from next video we're probably gonna get into the multivariate cases. And thanks for watching, and I see you in the next one.